Hello everyone, my name is Rushil and I am working on a research project for the Waikato Engineering Design Show 2021. I am a 4th year student studying towards the Bachelor of Engineering Honours majoring in Materials and Process Engineering. This year I have researched on the project of Characterisation and Treatability of New Zealand landfill leachate. I would be mainly focusing on the landfill leachate present in the Waikato region. This project would not have been possible without the help of my supervisor, Graeme Glasgow, so thank you very much, Graeme. Moving on to the contents. The focus of my studies was what is landfill leachate, how is landfill leachate characterized, leachate parameter data, how is landfill leachate treated, limitations and restrictions, and the recommendations. What is landfill leachate? Landfill leachate is a form of waste substance which tends to be toxic in nature and contains various organic and inorganic matters. The leachate forms due to percolation of water through landfill waste, and this causes a problematic issue for many countries across the world because of environmental hazards and the impact on the livelihood of people. How is landfill leachate characterized? The parameters for landfill leachate were characterized using the HAC-cod digestion reactor, Pellion test photometer, and the dissolved oxygen probe. These were used to characterize several parameters. This would be the chemical oxygen demand, biological oxygen demand, ammonia, nitrate, phosphorus, and chromium. As you can see on the left, there is a Pellion test photometer, which was used to characterize ammonia, nitrate, phosphorus, and chromium, as well as the HAC-cod digestion reactor, which was used to characterize the cod concentrations. The dissolved oxygen probe was used to characterize the biological oxygen demand. Next is the leachate parameter data. So the board concentration and phosphorus concentration start up at a high, then they fall off, climbing and then falling off and then reaching a peak again. These can also be seen for the chromium and cod concentrations, and this can also be seen in the ammonia concentration as aged leachate show a lower concentration while fresh leachate show a higher concentration. How is landfill leachate treated? The landfill leachate is treated through a biological treatment using a sequence batch reactor. Nitrification and denitrification is used during the treatment process. This is done over a 24-hour operation cycle for the landfill leachate treatment. Now initially the reactor is filled with 18 liters of raw leachate. Next, the leachate dosing occurs for an hour, where every 15 minutes it is run for 1 minute. Next is the aeration phase, which runs for 19 hours. Followed by the anoxic phase, which is for 2 hours. Then there is a settling phase for 30 minutes, a decant phase for collecting the treated effluent for 30 minutes, and then there is a rest phase for an hour. This video would give a breakdown on how the treatability of landfill leachate takes place using a sequence batch reactor. So you can see there's a digital timer there for the water pump, which will do the leachate dosing. The pipe is running through to the reactor. Here you can see that there's 2 air pumps. They are powered by 2 digital timers, and I'll show you how they were programmed. So you'll see now that there is the turning on phase. So the air pumps turn on at 11 a.m. and now the turn off, which is at 6 a.m. the following day, which is a 19 hours operation cycle. Now the same is being done for the second air pump. Now from the air pump we're going into the reactor, where you can see there's aeration taking place. Next there's the mixer for the anoxic phase. This is then programmed. You would be able to see it turns on at 6 a.m. and then you'll see the turning off at 8 a.m. That is a 2-hour anoxic phase for denitrification. Next is the solenoid valve. As you can see, it's decanted into the bucket below. It is programmed to start at 8:30 a.m. and finish at 9 a.m., which is 30 minutes of decant. Now moving on to the limitations and restrictions. Due to the COVID outbreak and lockdown restrictions, I was unable to acquire the leachate samples to conduct my experimentation. As an alternative, I was given data from previous experimentations on the leachate. Also, due to the current circumstances, the aeration efficiency experiment is yet to be conducted. My recommendation for future studies would be to utilize the high-performance liquid chromatography, as it offers higher analytical resolution for identifying and quantifying the various compounds present in the leachate. And secondly would be collecting the leachate samples during different seasons of the year, as concentrations of compounds vary depending on the climate. Thank you.